Hello everyone, my name is Ashkbiz Danehkar. I am a postdoc at University of Michigan. In my today presentation, I will talk about my study of electrostatics solitary waves in a plasma which consists of electron beams and inertial positron and inertial cold electron and hot superthermal electron, which modeled by Kappa distributions. Previously, I studied electrostatic solitary waves in a plasma which consisted of cool electrons and cool positrons, and I found the existence domain of soliton in this plasma. And also, I studied two fluids model which contained electron beams and also inertial electrons, and I found how electron occurs in solitary waves produced in this plasma. In my recent study, I consider a true fluids model which consisting of inertial cold electrons and inertial positrons fluids and drifting electron, which are also called electron beams. So we have three fluids model, and also we have hot Kappa-distributed electrons and stationary ions. And all these three fluids equations couple via Poisson's equations, which leading to following equations. Also, I use following normalizations factors and some constants and some definition, which is alpha, the density of hot electron over cold electron, gamma, the density of positron over cold electron, beta is density of the beam electron over cold electron, and U0 is equilibrium beam speeds, the speed of beam electron which normalized by the hot thermal speeds. And by using some linear approach, I obtained linear dispersion relations. I found dependent of phase speeds on different parameters. Also, I use some nonlinear approach, and which lead to stacked of pseudo potential equations. And in this nonlinear approach, I consider the fluid equation stationary frame traveling a constant, which transfer the fluid equation to this four equations, and combining them and integrating them, I obtain the following pseudo energy balance equations, which we have the definition of stacked pseudo potentials, which given by this equation. And this equation allows us to see the occurrence of and existence domains of positron acoustic solitary wave as well as electron acoustic solitary waves. And here F1 and F2 allow us to see the lower limit and upper limits for negative potential, which is electron acoustic solitary waves. And again, we have also solutions for positron acoustic solitary waves. And here we see the dependence of upper limits on gamma, which is positron density over cold electron density, and kappa, which is superthermality, and U0, which is the electron speeds, and beta, which is the beam density over cold electrons. And also, I see dependence of different dependence of a positron acoustic parameter on different parameter. I see the superthermality increase the amplitude of positron acoustic waves, and we see that also the increasing the beam speeds and beam density also decrease the amplitude of positron potentials. And we also see by increasing the positron, we amplify the positive potentials. So indeed, we enhance the positron acoustic solitary waves. So in summary, this study allows us to see the existence domains of positron acoustic solitary wave. We see that it's get narrower by increasing positron density, decrease in beam speed and beam density, and increase in superthermality. Also, we saw that reducing the kappa means increasing superthermality, and reducing beam density and increasing positron charge density enhance the positive soliton amplitude. Thank you for your attention.